Okay, chemist. So we're going to do an example where we take the formula and we write out the name of the compound. So you have this example right here in your notes. I want to do both an example of this one, because these are both copper oxide, but they're different in the way we write their formula. And what makes those different is the fact that the copper is a transition metal, and it can have a different valence or a different charge. So let's look at that. The copper, I do not know what its charge is, but based off of this formula, I know that there's one copper and one oxygen. Okay, well, it means I have one copper with some sort of charge, which I don't know. I'm going to call it X. And I have to add that to the charge of oxygen, which I do know. So there's one oxygen that has a -2 charge. And this has to be isoelectronic, meaning it has to be 0. So, what we want to do is we want to take this and let's just do some simple algebra. 1 times x will give us x. And then if I take this math over here, 1 times -2 will just give me -2. Has to equal 0. If I add the 2 over to the other side, this gives me x equals 2. That is very, very important. Because what that tells me, that x is the magnitude of the charge. That means that this 2 is the charge on copper. So I can now write the formula, and it would be copper, its magnitude, which is designated by a Roman numeral, and then oxide. And there we go. There's its name. I'm happy. Let's look at this second one. Still, it's copper oxide. We need to know the magnitude of the charge on the copper so we could write the formula name. So once again, I have one copper with some sort of charge. I'm sorry. I even messed up on the video. Let's see if I can erase this. There we go. I have 2 coppers. So I have 2 coppers, and I need to know the magnitude of the charge on them. 2 coppers for every 1 oxygen. Therefore, I know that I have 2 coppers with some sort of charge, and I have to add to it 1 oxygen with that -2 charge. Very similar to over here, except now instead of the 1 copper from over here, this one has 2, because there are 2 coppers there to where there was only 1 over here. Okay, so with that being the case, let's do the same math that we did on the other side. 2 times x will give me 2x. 1 times -2 will give me -2. It still has to be 0, has to be isoelectronic. Therefore, let's do the math. Add the 2 over to the other side. 2x equals 2. Let's divide away this 2. X equals 1. Very important for us because this is the charge on the copper. The charge is a +1. So now I could write the formula, and it would just be copper, the Roman numeral I for 1, oxide. So there is the difference between those two. The math in here came out to be a 2, so that means I have a +2 charge on the copper, so it's copper 2 oxide. Over here I had 2 coppers, so when I did all the math, I came out to get a +1 as a charge. Therefore it's just copper 1 oxide. Okay? So there's a lesson there. Hopefully that made sense. If not, please ask questions or watch this video again.